Hi, I'm Kris Oldland. I'm the Editor-in-Chief of Field Service News, and I'm here reporting live from the Field Service Management Expo. Here in London's Excel. It's been 3 days of heat, conversation around field service, and getting some great product launches in. And this is why I wanted to talk to the team at mplsystems. We're talking to Susannah and Neil from MPL, and they've launched perhaps the most exciting tool that's been discussed in the last 3 days. ESOP is a tool. Genetic algorithms are at the heart of it, which I want to find out a little bit more about. But Susannah, to begin, perhaps you could tell me a little bit about the launch. Tell me exactly what ESOP is.
Okay, so we've had a scheduling system now for about 6-7 years, which we deployed throughout the UK. Obviously handling planned visits, but also reactive visits. But one of the things we're noticing continually is, scheduling is really complex. Scheduling's been around a long time.
Absolutely.
No one does it well. The age-old field sales problem, getting a salesman to as many places before, started in the 60s, never been solved. However, even if you can do it vaguely well, what you find is you've got a plan, your engineers pick up their jobs in the morning through their mobile app. But what happens when they get stuck in traffic? What happens when they get held up on their job? What happens to their following jobs? A customer calls in with an emergency job, flood somewhere, they need an engineer out straight away, you've got to meet that SLA. And so managing all this reactive work that's flying in throws the standard schedule out. So what do most companies do to solve this? They keep some idle time in their schedule, but that means you're not using your engineering resource to its fullest potential. So what ESOP is really about is how can we do it? It's the next set of algorithms to solve this problem. How can we do that real-time optimization continually in the background without sacrificing engineering efficiency while still being really reactive to our customers? So that's kind of why we...
Sure.
So we won a grant about 3 years ago now from the UK government to develop genetic algorithms. Genetic algorithms are out there, Neil will talk a bit more about them, but to apply them to this problem was the purpose of the grant.
And just a very quick point on that grant. How did that come about? Because is this the government saying, look, is that them acknowledging the importance of field service? Because I think as an industry, we understand the importance. Yeah, we step outside of our bubble and we try and explain what field service is, and we just see blank faces. Is that perhaps an indication of the importance of the service culture within the UK?
Yeah. I mean, we very much position it as it's field service, but increasingly customer experience is the big player in this, and it's applying customer experience into field service. Increasingly customers are expecting more. They're not prepared to wait 2 days for a visit. Yep. They want a job when they want it, and they want it straight away. So we very much, the UK government have a scheme called Innovate, where they give money to small technology companies who are doing something really special in industries. To get that kind of grant, you need a really good business case. So we built that up around field service, but how field service is changing and adapting to the customer.
Excellent. Neil, let's talk about the technology. Susannah's already mentioned, and I keep getting this slightly wrong, but genetic algorithms.
I know.
This sounds like a great bit of pseudoscience or fantastic technology babble. Please make it more human for me.
Okay, allow me to explain and translate. Okay, from a technical point of view, normal schedulers, as we've done it in the past, schedulers work on a finite structure of time slots. And from that, you're trying to work out and fit in everybody. But the problem is, what happens after 9 o'clock and you've got your schedule out there when an emergency, same-day appointment comes in? You need to react. And finding that, as Susannah explained, trying to find that capacity to fit that job in means that you can't with traditional structures. So people end up leaving this extra space in. So the next evolution of this is to use genetic algorithms, which has come from a scientific, almost mathematical background, although we use the term genetic because it uses the principle of Darwinian survival of the fittest.
Right.
So after the initial calculation has been made, the system is constantly evolving. It creates little variations, mutations to the route. Instead of going straight up the main road and turning right, why don't we try this little A road at the side of it? Why don't we go behind this particular building? Lots of changes that go on. It's looking at lots of different data sets at once. We're looking at the weather, we're looking at the traffic, we're looking at, is there Glastonbury going to be there next week? All of this sort of information, and we're constantly evolving throughout the day so that if that emergency appointment comes in, if the engineer's tyre blows up and he can't carry on to his destination, the systems are automatically learning and immediately evolving to meet that demand, and the routes that fail to deliver the agent where they're going get killed off, and instead the strongest routes start to bubble to the top, and by the time the engineer's on his route to that next position, that's the dominant, leading, strongest route, and we know then we can be confident. Now, if we're using computers to calculate this, we have to be careful that some of the, let's say, humans that are involved in the chain that oversee these engineers don't fall into their old patterns of diving in and manually moving placement, because with a genetic algorithm, as soon as you disrupt the genome, as soon as you change the day, that system is going to want to evolve to meet that demand. It's going to want to grow and conquer that requirement. So making a small change, pulling a job off an engineer, the system will try and take into account that new preference, and instead it'll create a brand new structure, might even reallocate engineers from across borders. It's a wonderful thing to see it in action.
It sounds it's one thing that strikes me, and I understand where the genetic algorithm concept comes from now in terms of the Darwinian motion. One thing that strikes me initially is, would it not take quite a bit of time for that optimum route to be found? Let's say 6 months, 3 months, 2 months. Also, is it then best to first, I'm just thinking of people migrating to a system like this, would it be best to run it almost in tandem as it gets to a point where it's learned? Or can you go from day one and say, right, so I'm going to plug it in here, it's going to be as good as your existing scheduled engine, but it's just going to get better. Which way round is it?
Because it's a paradigm shift in the way the engine works, instead of trying to port all that old learning from the previous methodology of using these fixed time slots and timing it to 5 minutes, instead, if you do it's almost like a new world. By all means, you could try and have some of that knowledge, but the engine's already built up an understanding anyway. So as it is used, it will only become more smarter. But the very first day, you're already skipping that 30% retention that you're having to keep the engineers back.
But I think there is a certain amount of intelligence that so your planners, how they're working at the moment, they may be using automated scheduling, they may be doing it manually, but typically when we look at installations, we talk to Gartner quite a lot about this, and they've just done a report on this, and they said the majority of scheduling implementations fail within the first 6 months, and that's pretty much because the planners, because of this emergency stuff coming in, the planners ignore the automation and what it throws out, and they totally overrule it and override it, and then that throws the automated scheduling out. So eventually they lose trust in it completely. But what they didn't do when they were planning the implementation was actually take that knowledge that's in the planners' heads and use that to configure the rules that the algorithms are using. So it's that real setup phase where you've got to involve your planners at the early stages. And anything like ESOP, yes, it's having automatically, but in the back end, all those rules that it uses to manage the algorithms, they are configured precisely to an individual organisation's needs. Some organisations care about travel time. Some organisations don't care. If it's a high-value asset, they'll fly someone out there in the next hour to go and fix it. So every organisation's different, and you've got to take the intelligence out of your planners and put it into that system so it controls how the algorithms work.
One final question on this. One of the things we see in our space in the field service sector is technology is coming faster and faster and faster. It's evolving faster and faster and faster. This is a clear example of the next evolution of a tool, like you said, that's been around for a long time. We've seen it evolve continuously. This is obviously the far end of that. Is this proprietary? How long before genetic algorithms become a standard part? How long have MPL systems got shouting rights on this, basically?
So, genetic algorithms are out there. They're being used in a lot of different applications. What we did was actually apply it to field service. Doing that has taken some time to do. We've had that development time, we've gone through it. Now it's a commercial product that's out there and deployable. 2 years' time we could have some competitors, but we're out there doing it now, and these other guys can't do that. So we think we've got a fair lead on them.
Excellent. Neil, Susannah, thank you very much.